In the part 1 and the part 2 of the section number 3 of Blender Topology course, we covered a number of different tools, techniques related to topology like the correct edge flows, booleans, bevel tool and a lot more. And finally, in the part number 3 of the third section, we'll be focusing on some more topology techniques with some understanding of subdivision and other related topics to help you deal with some topology issues that you might face while modeling 3D objects in Blender. So to begin with, I'll first be hiding this mesh that we created with the two cubes joined together with the boolean operation. So press H to hide them. Now press Shift A, go to mesh and add a cube. Now suppose that with this cube selected, I want to apply the subdivision modifier. So one of the ways will be to go to the modifier properties, then click on add modifier, and then in the generate category, you can find the subdivision surface modifier. However, another way to do the same thing will be to use the shortcut of holding down the control key, and suppose I press 2, then this will add the subdivision surface modifier to the selected object with the levels viewport value set to that particular number which you pressed along with the control button. Now the subdivision surface modifier basically subdivides the mesh, resulting in the object getting a smoother look. Also, you can change the level of subdivision from the levels viewport value, and for the final version that you will render, for that you can change the subdivision value with the render option. Usually, it is suggested to either keep the same value in levels viewport and render, or else you can keep a higher value while rendering the final version. Now if I switch to the edit mode, then you will notice that around the subdivided cube, we are having a cage-like structure which is in the shape of the original cube. You can even check this by going to the subdivision surface modifier and turning off the display in the edit mode, and here we have the original cube with the same shape, same size back in the edit mode. But for now, I'll turn on the display option in the edit mode. Now the best part of using the subdivision surface modifier on any object is basically that you can make almost everything in a very simple manner just by using some basic tools in the edit mode. For example, suppose I press Ctrl R to add a loop cut here, then drag it on this other end. Now if you observe closely, then you will notice that on the end where we added the loop cut, this particular side of the face turned flat, whereas the other side is still curved. Now in the exact same way, if I press Ctrl R again and add one more loop cut over here, then now this side is also flat, and with this you can also notice that how convenient it is to make the changes in the geometry, and it kind of feels like you're playing with a clay dough where you just have to play around with the edges, the faces, and modify the geometry of any object in a very simple way. Like for these two faces, I just applied the extrusion tool, and now this is the shape that we get in the object mode. And here you can realize the actual importance of subdivision surface modifier, because if I go to the subdivision surface modifier and click on the apply button and then switch to the edit mode, then you can notice that how smooth the edge flow is and how perfect the topology looks, even though the shape of the object doesn't look to be very simple. And if you were to do the same thing without the subdivision surface modifier, then it would obviously take a lot of time to first dissolve the existing edge loops and then recreate the new ones by following the process that we learned in the last video. For now, I'll undo this until I get back the subdivision surface modifier in the modifier properties, and after this, the next thing that we'll understand will be the use of this value, which is the levels viewport, and its effect on the object's geometry. So suppose I bring this value down to 0, then here we get the actual cube with no subdivision surface applied, and if I switch to the edit mode, then basically these were the two faces that we extruded and managed to create that complex shape with the subdivision applied. After this, if I increase the levels viewport to a value of 1, then we'll get a low poly model which is kind of getting the shape that we wanted it to have, but it's still not perfect. Then if I increase this value to 2, then the level of subdivision will increase and we get a slightly more smoother geometry with more edge loops and a higher resolution. So basically, higher the value of levels viewport, higher will be the resolution, more detailed will be the object, but along with that, it will also take a much higher time to render. So as an advice, do note that if you're working on a very big scene where, let's say, you have some of the objects close to the camera and some of them are far away, then for the closer objects, do consider keeping the level value to something like 4, 5 or even 6, depending upon how complex or high resolution you want the structure to be. And for those objects which are far away from the camera, you can reduce the levels viewport value to a slightly lower number, let's say 3 or 4, as this would help you save the PC memory and some render time. So till now we discussed that by adding the loop cuts, you can make that part of the model sharper or basically flat, and then you can also move these edge loops around to adjust just the final shape. And now here is one more important thing that you have to take care while working with the subdivision surface modifier, which is that you should be having only the quad faces and not tris or n-gons as far as possible. If you remember, we discussed about the tris, n-gons and the quads in the early videos of this course, and now let's use that concept that we understood in this video also in order to see what exactly will happen wrong if we do not use the quads while working with the subdivision surface modifier. So over here, suppose I select these two vertices, then right click and apply subdivide, then this will give us n-gons in the geometry. Like you can see here that this face on the top is now made up of a total of 5 vertices, and similar is the case with this face also, and we haven't made any other changes in any part of the geometry apart from adding this extra vertex over here. But even with that, if I now switch back to the object mode, then right click and apply shade auto smooth, then this will smooth out the object. However, you will still be able to see these issues with the geometry, or basically the shading issues, which won't be fixed even if you increase the levels viewport value in the subdivision even to a higher number like 6. And that is exactly why I suggested you to always keep in mind that you should be having only the quads while working with the subdivision modifier. For now, with the extra vertex selected, I'll press X and dissolve vertices, and with this we again have a smooth geometry back in the scene without any shading issues. Now after understanding about the basics of the subdivision modifier and its usage, the various concepts of the subdivision in topology, it's now the time to move to the next topic of this video, for which I'll first be hiding this object, then press Shift A, go to Mesh and select the cylinder. Now with the cylinder added over here, suppose I switch to the edit mode, and now I ask you that is the topology of this cylinder completely perfect? Then most of you might reply that yes, the cylinder that I just added would obviously have a uniform and a correct topology, and it must not be breaking the so-called rules of topology that we covered in the starting videos of this course. But on a closer look, you should have observed that this top face of the cylinder is an n-gon, which is very clearly a violation of the first rule of topology, which was that we should always prefer the quad faces over tris and n-gons. Also, this does not mean that there is some error in the topology or the geometry of this object, because in the initial videos I also told you that there are no hard and fast rules that you need to compulsorily follow while working with topology and modeling. But yes, I told you that it's always better to try some way or the other to get the quad faces instead of the tris and n-gons. And in this case also, let's now see how exactly can we turn this n-gon made up of 32 vertices into several smaller faces with just 4 vertices each. So for the solution, first of all, with all these vertices on the top selected, press X and select delete faces. This will ensure that only the face on the top is deleted and not the vertices. After this, with the Alt key hold it, select the entire vertex loop on the top, press E to extrude, then right click, scale this down, and this will form the border. And then in the region inside this border, we'll be having the quad faces. And to add these quad faces, we'll finally use the technique which is the grid fill. To use it, with this vertex loop selected on the top, press Ctrl F to open the face menu, or else you can also go to the face menu from over here and then select the grid fill. This will basically fill the area inside the vertex loop with multiple quad faces, and also by using the span value, you can change the number of these grid columns, and then by using the offset value, you can basically change the way how the vertices are arranged on the corners. And now if you observe, we have all of the faces on the top part as the quad faces. Over here, this outer loop has all the quad faces because we extruded the vertices and then scaled them down, and then for the inner part, we use the grid fill tool. After this, I'll now be adding one more cylinder in the scene, and this time, in the number of vertices, I'll reduce this from 32 to an odd number, let's say 27, and after this, I'll again enter the edit mode, select the vertex loop on the top, press X and select delete faces, then select the vertex loop again, press E to extrude, then scale this down. And with all of the vertices selected, if I now press Ctrl F and go to grid fill, then you will notice that this time it did not work. So now you might be thinking that what exactly was the difference. Previously also, we had a cylinder in the scene, we deleted its top face and then used the grid fill to fill all of these faces, and similar is the case over here also, but on pressing Ctrl F and using the grid fill, we are not able to achieve the same result. And this is because for the grid fill tool to work on your mesh object, you need to ensure that the number of vertices which are selected on which the grid fill tool will be applied must be even. Now after this, I'll return back to the object mode, press X to delete this cylinder, and now I'll be adding one more cylinder in the scene, then change the number of vertices back to the default 32, and after this what I'm gonna do is that I'll be applying the subdivision surface modifier to both of these cylinders. This one is the default cylinder that we just added, and this one is the cylinder on which only the top face is having all the quad faces. So with this one selected, press Ctrl 2 to add the subdivision surface modifier, and on doing this, you will notice that we are getting very weird results, and no matter how you look at it, this thing that is in front of our eyes does not resemble a cylinder from any angle. And all this happened because of the default n-gons that a cylinder had. And now let's experiment the same thing with this cylinder with the quad faces on the top and an n-gon at the bottom. So with this cylinder selected, I'll be pressing Ctrl 2, and on doing this, we get to see a completely different result. On the top, we are now getting a flat face that we should be getting because that's what a cylinder is. Two circular flat faces with a circular body in the middle, and here on the bottom, we get the same result as this one because obviously we had an n-gon here similar to the top and bottom faces of this cylinder. Now if you want, you can make this upper part even more better by adding a loop cut like this. Also, suppose I add another loop cut and this time I push it down like this, then you would notice that on the bottom also we have a flat face. However, as you can clearly see, the geometry of this face is not perfect. In fact, to check this, I'll go to the object mode, then right click and apply the shade auto smooth, and on doing this, we'll be getting a flat face on the top which looks beautiful, but for the bottom, we get a very weird looking face which is kind of flat, but it's still not perfect because of the shading issues which are a result of this n-gon and a poor topology. And with this, we now arrive to the end of this video. Till now in this course, we have studied about a lot of different issues that can arise due to a poor topology with several examples, different ways to solve them. Like in some cases, you would need to use the knife tool, then in some cases you would have to fill the faces or maybe play with the edge loops in order to get a perfect or a good topology. And also, this finally brings us to the end of the section 3 of this course. Now in the next section, we'll be starting with creating a scene with an open book, and during that process, our main focus would not be to understand about the topology, but to actually understand some complex things related to modeling. For example, the use of curves to control the model, about the different types of modifiers, their usage, their effect on the geometry of an object. Then we'll understand about what things we need to take care while using multiple modifiers together, and a lot of new concepts. So don't forget to subscribe to this channel, press that notification bell so that you can get timely updates about the upcoming videos. Thank you for watching, and we'll see you in the next one.